In this video, I want to discuss the sampling distribution. So on Canvas, you will find a CSV, comma-separated file with every real estate transaction in Ames, Iowa from 2006 to 2010. There's also a smaller file, which I have displayed here, which contains just the above ground living area and sales price for these home sales. So again, if I look at this tab here called Ames Data, you'll see GR live area, which is the above ground living area, and the sale price for a home. Okay, this Ames sample.xlsm spreadsheet is designed to take a random sample of the data. To make the spreadsheet logic easier, what I did was I created a button. So you can see here on the left, there is a select sample button. And if you look on the right here in orange, in this orange table, is the sample. So if I click the button, I get a new sample. Now, this button does not need to be there, but I added it really to improve the performance of the spreadsheet. So basically, I could have created, and in fact did create, do all these calculations, create the random sample, so that when you recalculated the spreadsheet, it gave you a new sample. But for my purposes, that was too slow, and thus I moved most of my logic away from the spreadsheet, or away from the spreadsheet that you see, into the Visual Basic. Visual Basic is a great skill. Visual Basic, being able to add a button using Visual Basic is great. Beyond the scope of this course, there is a course called BAIM 3210 if you are interested in that. Okay, so when I push this button, select sample, you can see I get a new sample. There are 50 observations in my sample. So basically what my Visual Basic does is it goes to the data that is here and chooses 50 different rows. So for example, it could choose this one and put 1004 as the above ground living area and 149,000 as the sale price into this table. It chooses 50 of those and gives me a sample. Okay, so what we're going to talk about here is the difference between the population and the sample. So first off, we have been calculating means and standard deviation. The mean and standard deviation of a population is called a parameter. The mean and standard deviation of a sample is called a statistic. So if we know the population, and in this instance we do because we have all of the home sales, then we can know the parameter. If we only have a sample, then we know a statistic, and what we'd like to do is infer what the parameter might be. Now, to compute a mean, we take the average. To compute a standard deviation, we use the function stdev, and either we use stdev.p if we have the entire population, or stdev.s if we have a sample. So now what we want to do is estimate the population mean based on a sample. So the most intuitive thing we can do is take the sample mean. So for example, this is a sample of living area. We've got 50 of those, and we've taken the average of those, and that's our sample mean. This is called a point estimate of the population mean. Now, every time I choose a new sample, I get a different sample mean. So I get a different point estimate, and the sample mean, as you can see, is close, but never exactly equal to the parameter, the mean that we would like to know. Okay. Now, what we can do is we can think of these 50 observations that we're choosing in each sample by clicking the button. as being drawn from a distribution of point estimates. So imagine that we could look at every single point estimate. Then when we choose a particular sample, then it's one of those observations of the point estimate. So we can think of our point estimate as being drawn from a different distribution. So the second tab, the sampling distribution, allows me to create samples. So each sample contains 50 observations. So here I'm going to create 10. So here are 10 samples. I can do it again. And so basically what this is doing is each row here is as if we pushed this button 10 times. And we recorded the mean of the living area and the mean of the sale price. And we get some data. What I've done is created a histogram. Now, what I'd like to demonstrate here is, what if we do this 1,000 times? Bottom left, you can see a counter. That counter is telling us how far it's gotten through the 1,000 observations. It's actually just stopped updating my screen because it was updating too much. And in a second, it will come back with our 1,000 observations. So we have done 1,000 point estimates of the living area mean and the sale price mean. Now, what is happening is this is using VBA to essentially push this button 1,000 times. And we can look now at this histogram. So we have a histogram of the living area point estimates and a histogram of the sales price point estimates for the mean. And what's happening is that these point estimates, the distribution of point estimates, is pretty close to normal. So we end up with a normal distribution. And we know these estimates, these point estimates, are never exactly right, never exactly the population mean. But on average, they are the population mean. So we have this distribution, the sampling distribution, and the sampling distribution has mean, the actual population mean. And then the sampling distribution has a standard deviation. We call that standard deviation the standard error of an estimate, and it is given by sigma x divided by square root of n, where sigma x is the population standard deviation and the square root of n is the number of observations. And of course, if we have a larger number of observations, we are going to have a smaller standard error.